Hello, welcome back. I'd like to work with you on the formulas for integrals involving the exponential function. So what I want to answer the question is, what's the integral of e to the x dx? For most of these integration questions, they come from the rules for derivatives. And so if you have good command of the rules for derivatives of functions, then you can remember the ones for integrals. Now, I really like e to the x. It's one of two functions that are their own derivatives. They're zero, kind of the silly function, or e to the x. Oh my gosh, it's so cool. The derivative of e to the x is itself e to the x. Oh, that is so cool. Well, that means that the integral of e to the x is e to the x also, except there's this constant of integration that pops up because the derivative of every constant is 0. So the derivative of e to the x is e to the x. The integral of e to the x is e to the x plus c. Okay. I'd like to remind you also that the derivative of e to the k times x, so I'm scaling my function k right there, is equal to k times e to the k times x. That's because of the chain rule, because I take the derivative of e to the x and then I take the derivative of the inside, and I get the derivative of kx on the outside, which is just k. So let's see how that works when I want to integrate e to the k times x dx. This is for k being a constant and only a constant. This does not work if it's like x squared. That's some other game entirely if it's a more complicated function. So this only works if we have a linear function upstairs. Okay, so when I took the derivative of kx, I got a k on the outside. So when I took the derivative, I multiplied by k. So that's when I integrate, I'm going to divide by k. So this is equal to e to the k times x over k plus some constant c. Now let's check our work. When I take the derivative of e to the kx, I get a k on the outside. It cancels with this one, and I end up with the coefficient of 1 that I had on this side here. And the derivative of every constant is just 0. So those are the integrals of exponential and exponential with a linear function right here. I wish you all the best for doing your integration, and we'll see you again next time.